Welcome to Objective 6. So you've had your initial introduction to radian measurement in Objective 5. I know it was a lot thrown at you. It always is because it's something brand new. You've never heard of a radian before probably, and so it's going to take a while to get used to. Plus the fact that we're working in fractions, that never helps. So let's go back to everything revolves around this equivalency right here. If you're talking in terms of degrees, then 180 degrees gets you halfway around the circle. We all know that. But in this new unit of measure, the equivalent to that is a 1 pi radian. And then, of course, if 1 pi takes you halfway around, then 2 pi will get you all the way around. But we're going to work with this 1 pi equivalency right here. The fact that 180 degrees equals 1 pi radian. So, if 180 degrees equals 1 pi radian, what is 1 degree? Well, all I want to do is I want to turn this 180 into a 1, and that means I divide by 180 degrees. I'm just doing some simple little algebra here. Now, what that makes is 1 degree equals pi over 180 radians. Now, what does 1 radian equal? Well, I'm going to start with the same equivalency again, but this time it isn't the 180 that I want to turn into a 1, it's the pi that I want to turn into a 1. So I have to divide both sides by pi. And what that gives me is the identity of 180 degrees over pi equals 1 radian. So, here are the two identities I'm going to use. So, to convert from degrees to radians, what I need to do is I need to multiply by pi over 180. And to convert from radians to degrees, I need to multiply by 180 over pi. So, example A, what is the equivalent of 7 pi over 10? Well, we're in radians right now because of the pi. Okay, that's going to change next year if you're in advanced math. But for right now, if we see pi, we know we're in radians. So, I need to go from radians to degrees. So I'm going to start off with the radians that were given to me, 7 pi over 10. Now, to convert from radians to degrees, I multiply by 180 over pi. Now, here's a way I help my students with this. If I'm in radians, I'm going to see a pi. If I'm not in radians, if I'm in degrees, I am not going to see a pi. So that pi has to somehow cancel and go away. Well, it isn't going to cancel and go away if I multiply by pi over 180, but it is going to cancel and go away if I multiply by 180 over pi. So that's what I'm going to do. My two pi's right there are going to reduce each other. And now all I've got is 7 times 180, which is 1,260, over 10, which is 126 degrees. Now, let's go the other way. What would be the equivalency of 250 degrees? So I'm in degrees, and I'm going to go to radians. Degrees to radians. So I'm going to start off with the degrees that I know, 250, and I'm going to multiply by pi over 180. Because again, if you use the same little memory device that I told my students, is these degrees do not have a pi in them, and they're not going to have a pi in them. Degrees is not going to have pi, but radians is. So between these two things, which one am I going to have to do that makes the answer include a pi? Well, pi over 180. So what this is going to be is 250 pi over 180. Now, I can divide both of those by 10, so I can reduce by a factor of 10, and I'd have 25 pi over 18 as my answer. So that would be the answer to that problem. For the next part of the worksheet, we're going to look at a lot of familiar things. The first thing we see is the SOHCAHTOA, the trig functions. The next thing we need to make sure we remember is what quadrants are the trig signs positive. So all students take calculus. Let's see, the next thing. We need other information for sine, cosine, and tangent, because what if we're on a quadrantal? If we're on a quadrantal, SOHCAHTOA really doesn't help us. So sine, in addition to being opposite over hypotenuse, is also y over r. Cosine, in addition to be adjacent over hypotenuse, is also x over r. And tangent, in addition to being opposite over adjacent, is y over x. Now that's if you're on quadrantals. You're going to need this information if you're on quadrantals. Now, let's get to some of the new stuff. We know certain degree measurements, but let's look at what are their equivalencies in radians. Well, we already know 180 degrees simply equals pi radians. And we know 360 degrees equals 2 pi radians. But what about those special right triangles? We know those in degrees, but we also need to know them in radians. So let's take this triangle right here. Okay, this is my 30, 60, 90. So my reference angle right here is at 30 degrees. But what is the equivalency of 30 degrees in radians? It's pi over 6. So 30 degrees is pi over 6. Now, does that change the measurements of the 30, 60, 90 triangle if we name it pi over 6 instead of 30 degrees? No. It's 1, 2, and square root 3. Now, if you are in the unit circle, remember that 2 wouldn't be a 2, it would be a 1 because that's the radius of the unit circle, and this would be 1/2, and this would be root 3 over 2. Now, what about let's go to the 45 degree triangle right down here. Okay. We know 45 degrees is 45 degrees, but what is it in terms of radians? Okay? It's pi over 4. And we know that usually the 45, 45, 90 triangle goes 1, 1, and square root 2. But if it was placed in the unit circle, the hypotenuse would be the radius, and it would be 1. This would be 1 over root 2. And this would be 1 over root 2. I know by now you have all of this in your notes, probably in several places. So the 45-degree angle is pi over 4. Now let's go to the 60-degree angle. 60 degrees is the equivalent of pi over 3. But it doesn't change the format of the triangle. The smaller side is still the 1. The hypotenuse, I'm supposed to do these in red. Let me stay consistent. Okay, the smaller side is 1. The hypotenuse is 2. And the longer of the two legs is square root 3. But if we placed it in the unit circle, it would be the hypotenuse that has a radius of 1. This would be root 3 over 2. And this would be 1/2. Like I said, I know you've got all this information in probably several places in your notes. But the fact that we're putting them here again just tells you how important they are. Now that takes us to the 90 degree. If 180 degrees is pi, then half of 180 is 90, so 90 degrees would be pi over 2. Okay, what if you were given theta equals 11 pi over 3? Now the first thing we know, we're in radians because we see the pi. So let's figure out where 11 pi over 3 lives on the graph. Now it's positive, so we're going counterclockwise, and we're in thirds. So that means when I get halfway around the circle right over here, I'd be at 3 pi over 3. Because 180 degrees is 1 radian. So 3 over 3 is 1. Now, if I got all the way around the entire circle, I'd be at 6 pi over 3, because that's 2 pi. Now, if I made it all the way around again over here, I'd be at 9 pi over 3. And if I made it all the way around again, I'd be at 12 pi over 3. But that's where we encounter a little problem. We didn't make it all the way to that 12 pi over 3. So we didn't make it around the circle twice. We stopped a little bit short of 12 pi over 3. So that means my terminating ray is definitely in quadrant 4. So there's my terminating ray. And since my angle is 11 pi over 3, and this is 12 pi over 3, remember reference angles are always from the horizontal. So all I have to do is take 12 pi over 3 and subtract the 11 pi over 3 to see that my reference angle is really pi over 3. So that's my reference angle. But I'm in quadrant 4. So all I have to do now is go back to our 30, 60, 90 triangles. I've got them right here. Okay. Notice I have it marked in both degrees and radians. So I'm looking for pi over 3. So here's the triangle I want right here. And from here on out, sine, cosine, and tangent is just right in front of us. The sine is root 3 over 2, opposite over hypotenuse. the cosine adjacent over hypotenuse is 1/2, and the tangent is opposite over adjacent, which is √3/1. So I'm going to transfer all those numbers to right here. Sine is √3/2. Cosine is 1/2. And tangent is √3. And if you want to call it √3/1, sure, go ahead and do it. Now, the last thing we have to worry about are the signs. We're in the fourth quadrant. All students take calculus. So cosine is the positive trig function in quadrant 4. That means the other two are negative. So we have to throw a negative sign in front of sine, and we have to put a negative sign in front of tangent. Now, moving on to the next one. Negative 13 pi over 4. Okay. Well, negative means we're going to go in the other direction. We're going to go clockwise, not counterclockwise. But if I went halfway around, I'd be at 4 pi over 4. If I made it all the way around again, back to where we started, I'd be at 8 pi over 4. If I made it all the way around again, I'd be at 12 pi over 4. And actually I did. Okay. Remember, I'm going in the other direction. So we went to 4 pi over 4 right there. We made it back to 8 pi. Then we made it over here to 12 pi, negative 12 pi over 4. And now I've got one more pi over 4 to go to get to 13 pi over 4. So I know I'm in quadrant 2. Because I went to negative 13, negative 4, negative 8, negative 12, and then one more pi over 4. So that means my reference angle is pi over 4. And I'm in quadrant 2. So all I've got to do is go back to my triangles again. Pi over 4 matches up with 45 degrees. That's what pi over 4 is. It's the equivalent of 45 degrees. So I'm going to use this triangle to tell me my sine, cosine, and tangent. Sine opposite over hypotenuse, so 1 over √2. Now, if you need to rationalize it, that would be √2 over 2. Cosine, same thing, 1 over √2, or in its rationalized form, √2 over 2. And then tangent, opposite over adjacent. Any way you look at it, 1 over 1 equals 1. Now, the only thing I have to worry about is which ones are positive and which ones are negative. I'm in quadrant 2. Sine is positive in quadrant 2, so that means my cosine is a negative value, and my tangent is a negative value. Okay, let's do one more example, and you'll see how this is a little bit different. What if theta was 10 pi over 4? Well, first thing we need to always do is see, where does that take us? Well, we're in fourths. So halfway around the circle would be 4 pi over 4. All the way around the circle would be 8 pi over 4. If I made it all the way around back here again, that would be 12 pi over 4. But I didn't make it. I only made it to 10 pi over 4. So remember, this was 8 pi over 4 right here. This was 12 pi over 4 right here. So 10 pi over 4 lies right in the middle of those two things, which means I'm on a quadrantal. So this would be where I am, right here. Okay, I'm definitely on a quadrantal, so my reference is a quadrantal. Okay, between 2 and 3. Between quadrants 2 and 1, actually, I'm sorry, not 2 and 3, 1 and 2. Between quadrants 2 and 1. Now, what's going to help us with sine, cosine, and tangent now is not making a triangle or opposite over hypotenuse or anything like that. It's going to be the ordered pair of that position right there. And the ordered pair of that position is the x-coordinate is 0, the y-coordinate is 1. And now I'm going to have to use the other definitions of sine, cosine, and tangent. Sine is y over r, cosine is x over r, and tangent is y over x. Now, the radius of the unit circle is always equal to 1. So, for sine, it would be the y-coordinate, which is 1, over 1. So 1 over 1, which is 1. Cosine, x over r. Well, the x-coordinate is 0, so that would be 0 over 1, which is 0. And then we have tangent, which is y over x. So the y over the x would be 1 over 0, which is undefined.